up, everybody? Episode 20 here. I want to give a big thanks for everybody that's made it this far through the build series. I think we're at 151 subscribers at this point. So big thank you to guys. Really, I've only been posting for 5-6 weeks maybe. Whatever. I don't know. You do the math. 20 episodes every other day. Boom. That's the math. So what we got going on today is we're still working on the rear end, okay? This is actually the very next day from the episode 19. And I want to talk about metal prep and getting ready to actually start doing some welding and some actual fabrication. I want to talk about some techniques on how I cut things and stuff like that, really. So this is just going to kind of be metal fabrication and metal prep, and I want to dig into it. So I got all the 4-link plates prepped. The housing ends, I changed up how I was going to do them. I ended up cutting them so that they sit nice and flush and have a bigger shoulder to weld onto. And then I want to talk about some more in detail of how I clean the rear end housing and the actual abrasives that I use to do it. So let's go ahead and jump into it. The first thing I want to talk about is the housing ends, okay? So let me move these real quick here. So we got our housing ends here. Now originally these housing ends had a standoff on them, okay? So originally when I bought them, they were like this. They had that little standoff on them. Now this standoff is smaller in diameter than the axle tubes. I think this was like 3-inch or a little less than, no, I think it was 3-inch. And then this is 3 1/4. So what was happening is it was kind of sitting in like this. So then the axle tube, you'd have to weld, and the axle tube itself would be the larger part. So you'd be welding to a shoulder like this. And not that I think it would break like that by any means, but it's definitely not the strongest way I could do it, okay? So having this be the smaller diameter is just gonna make this technically the weaker point. Well, if I can get rid of the smaller diameter, why wouldn't I? And that's what I was seeing most people do. So what I ended up doing is cutting it off. So now what we got is a shoulder that I'll just be able to weld on, okay? So now the only weak spot is the whole axle tube. So the whole axle tube is the same diameter. The weakest point's gonna be the axle tube after I get a good chamfer. I'll have a good chamfer on here, and then I'll weld it to this. So there should be good full penetration, whatever the thickness of that tube is. You know, that's probably close to a quarter inch wall. It's probably some metric size or some nominal number that's under 1/4 inch, but yeah, so that'll be welded like that. And I want to talk about how I cut these nice and straight. Now, I thought about taking them to the machine shop at work, having the guys just cut it off straight, but I knew that I was able to do it away here in my garage, and I could do it pretty accurately. I'll post some pictures probably right here, or actually I'll probably wait until after I'm done talking about it, and then I'll post the pictures. How's that? So we'll finish talking about it. I want to show you guys the process of me cutting this. Now, to be honest with you, the way that ledge was, you could have easily just clamped this down and cut it with a die grinder and a cutoff wheel. You could have done that, and it would have been pretty straight. If you're nice and gentle and you just come in here and set that on that ledge, and you went all the way around, turned it, clamped it, and did that, and then, you know, pushed it up on the belt sander, that would have been a pretty straight cut. I have a Evolution saw. This is a 15-inch Evolution saw. I have a 14-inch Harbor Freight, or I'm sorry, 12. I'm sorry. I think this is a, yeah, this is a 15-inch saw, but I think I have a 12-inch blade. This is a Harbor Freight Hercules blade. It's meant for steel cutting. I think it was like $60 or $50 compared to the Evolution steel blade, which was I think 90 or almost $100. So it was substantially cheaper, and really the diameter difference is just how thick of a material you can cut. I won't be cutting anything bigger than 3 inch, probably 3.5 inches. So that size was perfect. This stack up here that I made to cut these is 4 inches, and it had plenty of room to cut it. I'm sure the 12-inch blade could probably still cut close to 5 inches or 4.5 inches. I didn't have any problems with them, and that blade is actually better than the one that came with it. The blade that came in that saw originally was a multi-use, so you could cut it on wood and metal. I didn't really like it. That steel-only blade from Harbor Freight's a pretty solid unit. So I stacked up 2 pieces of steel like this, okay? And then what I did is I took one of my right angles, I set that there, and I clamped this in there like this. And again, I'll post a picture of this setup right now. And then after I had it clamped in there, so I actually had to, I'll first say I had to make this, right? So I took these, I set them down like that, made sure that they were flush, and I tack welded them together. So there's just some tack welds, 6 spots, some tack welds. And then I put it in the saw, took my angle finder, made sure the saw is 90 degrees. All right, so I set this thing on its side, and I make sure that this is 90 degrees. So I make sure my deal here is 90 degrees, okay? And then what I'll do is I'll just skim cut this with the saw. And then that gives me a good flush edge, which you can see. If you focus on the tubing, not the what's left of the end cap there, but the actual square tubing itself is nice flush cut. So flush cut it, put that in there, tacked it on there, put it back in here, right? I set that on it, zero it. I set this on the rear cap. This cap here is like that, right? I set it on there, and then what I'll do is I'll knock it around a little bit with a brass hammer and make sure that it's at 0 degrees, which this is at 0 degrees. And then I cut it. And that's gonna give me a good cut, a good surface, and then I clean it up with the belt sander to make it look nice. Because once it cuts down to where that tube stops, it breaks off. So there's actually a little bit of a surface down here that doesn't have a blade mark on it. Because what I was doing is I was letting the blade touch this whole back surface. That way it just had a nice flat surface. But it would leave a little mark down here, and then I just hit it on the bandsaw, and it's good. Then I set it down on a flat surface. Measure the inside all the way around like this, just to confirm that this thing's nice and parallel. So that's how I cut both of those. I cleaned it up on the bandsaw. Boom, those are ready to go. And then for the rear end itself, I will actually get it inside this saw and do something similar. I will make sure that this is 90 degrees to the blade and it's straight, and I'll get it up in that saw, and I'll actually use this to make my final cut. All right, so these guys are all set. They're ready to go. Now, my Tin Soldier 4-link brackets. In the last video you saw, these were just raw, mill-scaled brackets, okay? Now, anytime you're welding, 2 things you don't want to weld to the mill scale. The mill scale takes more amperage to burn off, and then it also can leave deposits in the weld. It will look dirtier, it will be dirtier. It's just better to get rid of the mill scale. The only thing that I got left to clean up is the inside of this, and I haven't done that yet because I don't necessarily want to make it bigger, just in case it fits loose on these. So I held off on that, but I will eventually clean them up one way or another. It's just how I do it that's going to matter. I cleaned up the inside of these because these will have tubes. I still have to clean up the inside of this, but I don't have anything small enough necessarily. This is 1 inch. These are 1.25 inches. This is 1.5 inches. So I still got to clean this up, still got to clean this up. But this thing surface and the edges, all the mill scale has been removed. And how I did that is I lay down a piece of paper towel on my steel bench. If you got a wood bench that you work on, it's probably a lot better, to be honest. But being on a steel bench, what'll happen is the metal dust will actually kind of create like little ball bearings, and it will scratch up the surface. So I do it on a paper towel. That way I can clean the paper towel, shake off any of the metal, and do it. I use a Ryobi sander. This is 60 grit. I did all 4 of those, so 8 sides with this. And I cleaned my table with this one recently. These will last forever. It's a Diablo sanding pad. So what I'll do is I'll go over it, and then I'll wipe it with some acetone. Where's my acetone? Oh, right here. There we go. So I'll wipe it with some acetone and paper towel, and then go over it one more time. And the reason why I do that is that metal dust will kind of build up in all the pores and everything, and you'll notice that it doesn't really get any cleaner. You wipe it with the acetone and then hit it with the sander again, and it brightens right up and looks super clean like this one does. And then I'll flip it, do the other side. Now, to do the edges, you can do them by hand with like a little DA. You could use a flap disc. You could use a little Scotch-Brite pad. You could do it a couple different ways on the edges. But I do have a belt sander that I can put a Scotch-Brite belt on. And so I just come across here and walk it all the way across and clean up all those edges. And then the inside holes, I just use a little air die grinder with a 60 grit drum. That's a 1 inch 60 grit drum. And then for these guys, these are the 1/8 inch doublers. So all of these will get welded there and there on all 4 of them. These guys, I just use this. So I do the edges, and then I come down here and I walk it like this, flip it, walk it, rotate it, walk it, flip it, walk it. And that leaves a pretty solid surface on there. It gets rid of all the mill scale. It makes it very quick to clean up. And then you guys will see in a welding video very soon how nice and clean this should weld up, okay? So I might have to get some rod. I got to check what rod I got. But I'm going to go ahead and get the doublers all welded up. I'm going to get the axle tubes cut, all right? And then I got to get some tubing. I got to get some 1.5 or 1.25 inches. I think I have some 1.25 inches. I just need a couple little sections. So a few like little 1 inch sections. So I'll probably be good there. But I don't have any 1.5 inches or 1 inch. And that 1 inch is going to come across up here and brace up here and then across. And then that 1.5 inches will come down, brace at the bottom, and then come across. So I got to get some tubing to get those on. Those are ready. I got to make some cuts. I'll also post a picture right now of the dimensions of the tubes. So the last video we talked about pinion offset, and what I did is I took those measurements, put them in CAD with the brake hub offset and all that stuff, and got my tube lengths. So what I can measure from here and cut, and measure from here and cut. I got my tube lengths, so I'll post that right now. And then since all that stuff's done, I should be ready to rock on some actual fabrication, cutting, welding, and getting this thing good to go. I want to touch real quick though before I leave you guys. This is the wire wheel that I use. It's a DeWalt wire wheel. A bunch of people make a good, I believe they call them a coarse wire wheel, but it's just these twisted ones. I really like these. You just have to be super careful with your PPE because as you're using them, it will literally shoot needles, little stainless steel needles right through your jeans, right through anything you're wearing pretty much. So I'm always just kind of cautious of when I'm using them and just being very aware of where I'm pointing it, where it's at, and all that stuff. And then for flap discs, you can use some cheap ones. These are some cheap ones that I found at Menards. But to be honest with you, these Bauer ones from Harbor Freight are pretty good. They're not the cheapest zirconia alumina flap discs to buy though. So if you're at Harbor Freight, they're convenient to buy. You can definitely get some on Amazon and online. I'm trying to think. There's an abrasives company that's pretty. There's a couple different abrasive companies that are pretty good online that I've used in the past. But I recently tried these. I don't know how to pronounce it. Preferred maybe. They sell these at Menards too. Yeah, Preferred. They're made in Germany. And you can see how many is on there. I mean, this thing is just littered with sanding discs, and it lasts a really long time. This is a 60 grit one, and it leaves a really nice finish. So this is actually what I finished this tube with here. So I was really happy with how that turned out. I don't like spending a ton of money on these. These were like $5 or $6 each. So it's a little expensive. But if I only use them for the finishing touches and stuff like that, it's okay. Yeah, so 60 grit flap disc on this whole thing after I wire wheeled it. So I went in with this wire wheel and I went everywhere on it. But there's still some really hard rust flakes, I guess you could call them, that I'll probably go in with an actual like air handler or descaler and try and knock off some more of. And then I'll go back in and wire wheel it again. Or I'll just leave it for hopefully the powder coater to get after. Anywhere I'm going to be welding, up in here and stuff like that, I really went after it with the flap disc and got it knocked down. I hope that helps you guys on some of the metal fabrication, cutting, and prep work that I go through, just to kind of get to the point of saying I can start striking an arc. I like to do things to my fullest a lot of times. You'll see me skip steps. You'll see me not necessarily half-ass things, but take the easier route sometimes. But when it comes to me getting the final product ready on things, I like to really get it dialed in. So I like to make sure I got things cut. I like to take a moment and draw a CAD file and make sure I got my measurements good, that I'm not just doing it on paper and math correctly. So I just double check everything I can. I go through and try and clean my metal the best I can. And I think it will look the part when it's done. And that's part of what hopefully makes this build special at the end of the day, you know, is really just making sure that I've done my due diligence and taken my time and don't half-ass everything. So you guys have a good night. I hope you learned something. Take it easy.